Hi there. Thanks for joining us for Programmers Week. For those who may not know me, I'm Guillermo Murano, and I'm a community lead and senior software developer at Cognizant Softvision, where I'm in charge of designing and developing applications. And I've been here for the last 3 years. I'm really excited to talk about Azure Functions in Net 5 and encourage you, every one of you, to share your questions in the chat module so I can answer them accordingly. So let's get started. This is going to be our agenda. We're going to talk about what is Azure Function, a brief introduction, the differences with the previous net versions, what is an isolated process. We're going to dive a bit into the code and the differences between Azure Functions in Net Core 3 and Net 5. And we're going to have a bit of Q&A. So let's talk about what is an Azure Function. Azure Functions is a serverless solution that allows you to run less code, maintain less infrastructure, and save on costs. It scales automatically to meet demands, and instead of worrying about deploying and maintaining servers, the cloud provides all the up-to-date resources needed to keep that functions and applications running. So in that block of code that runs anytime you need with a different type of response according to the events. It's going to meet the demands with as many resources and function instances as you need, and only when they are needed. And it has several supported languages such as C#, F#, JavaScript, Java, PowerShell, Python, TypeScript, and it also has a custom handler that lets you create some other functions in other languages, for example, Rust or Go. A function has triggers that are the ones that causes a functions to run. They define how a function is invoked, and there can be only one trigger per function. As an example, we can mention the service bus queue trigger that runs whenever a message is added to a specified service bus queue, the HTTP trigger that runs when it receives an HTTP request, the timer trigger that will run on a predefined schedule with a cron. Queue trigger will run when a message is added to a specified Azure queue storage. We're going to have also a blob trigger that will run when a blob is added to a container, an event grid trigger that will run when an event grid receives a new event, an event hub trigger when an event hub receives a new event, the service bus topic trigger that is going to run when a message is added to the service bus topic, and the customer DB trigger when a document change in the document collection. There's also a binding for the functions. That is a way of declaratively connect another resource to the function via an input as a parameter, output, or both. They are optional, and a function can have one or multiple of them. So for example, for a HTTP trigger that receives an ID, you can just add it there, and it's going to be received as a parameter for that in the query that you trigger. So let's talk about the differences with the previous .NET versions. We're going to have the isolated process as the way you run the function in comparison with the in process that was the way that we used to run them. So let's talk about what is the Azure Function host a bit. That is the runtime that powers the function and runs on Net and Net Core, having the functions to run the same process and the host, providing us with a set of bindings and SDK injections, such as the bindings that I mentioned, triggers. You can trigger directly to the SDK and the types that are defined in the host process. So that way the host and the functions are tightly coupled in a way to run with the same version. So why was defined this change? There are still dependencies restrictions on how much of the process is customizable by the user. And in older versions of the functions, there were some dependencies conflicts in the libraries. For example, there was a known conflict with the Newtonsoft JSON library. And on the other hand, other languages mentioned supported by Azure Functions use out of process that runs the worker in a separated, isolated process from the host, supporting a quick support for new language versions without host updates. So that's why it was decided to migrate from this in-process to an isolated process. The in-process was used to run a class library in the same process as the host service. It provides a deep integration between the process and the function. And as I mentioned, the net function needs to be tightly coupled to the host process, requiring net function to run the same net version as the function runtime. On behalf of the isolated process, it runs separated, avoiding conflicts with different versions of the same assemblies. You are going to have full control of the app startup and can control configuration used and the middleware that you started. And you're going to have full control of the process, allowing the current net behaviors such as dependency injection or incorporating middlewares in the functions that wasn't allowed. So this is a table that we can see on the main differences between one and the other version. You're not going to have the SDK function. You're now going to have the workers and the worker SDK. You're going to have a different set of bindings. You can now obtain the logger from the context instead of passing it to the function. For now on this version, you are not going to have cancellation tokens. I know it's not yet supported the durable functions, for example, or the imperative bindings that it's thought to be in further net versions. As we can see, the supported versions for this, the isolated process will run from net 5 till net 8, where it's going to be the way to build functions. And the in process, it's going to be left aside after the net 6 version that is going to be released next November. So let's talk a bit about the isolated process. As an isolated process, the Azure Functions runs that autos process as a console that targets the net 5 framework. The basic requirements are the host JSON that contains the global config options, the CS_proj file that defines the project and the dependencies. You need the local settings that stores the app settings, the connection strings, and other local development settings, and the program that will be the entry point for the application. The functions needs to run through a console or PowerShell, for example, as an isolated process in order to run. And if you want to debug, you need to add that debug extra sentence. And then for debugging, you need to attach the process to the Visual Studio as we used to do for web services. For the side of the package services, we have now, instead of the web host, we're going to have the workers and the worker SDK that are required to run net functions as isolated. And you're going to be building an executable that imports the Nugget packages. And the app, as I mentioned, will include that program CS that will start the worker. You have now a new binding model that instead of the web jobs, you're going to have a different different worker extensions for each one. For example, if you want to build an HTTP trigger, you need to add the nugget package for that worker extension HTTP trigger. You now can inject your services and dependencies in a similar way as the one used in ASP.NET for dependency injection. It now supports middleware registration following the same method that you're going to see for dependency injection, giving you the ability to inject logic into the invocation pipeline for pre and post execution. You there can access the requests or the responses before accessing the function or releasing the response. And also you have the execution context in the function, where you can pass through a function context for objects that provides information about the execution. You can there have access, for example, to the logger that, as I mentioned before, you're not needed to pass it through the function, but it's going to be in the context. Okay, so I can show you a bit of the code and see the differences between both types of applications. So here I have a function that it's built in NetCore 3.1. As you can see, it's plain simple. You're going to be returning an OK object result in this case for the HTTP triggers, or in case of a timer trigger, just I'm just logging information. If I want to authorize, in this case, I built a simple authorization. It can be done using filters. Here we can check that we have the filter for that. That is going to be checking the HTTP request. The only issue with filters is that you can see here that it's a mark in the IDE that this function executing context is deprecated. And that was the way you can achieve that. Besides it was deprecated, there was no further version on how to achieve this. Also, if you want to handle the exceptions, you're going to need to handle that in a function exception filter that it's also deprecated, because, as I said for the other case, there was no implementation done for this. It was supposed to be in a further version, but it didn't happen. In case we wanted to create dependency injection, we had a startup method where we needed to add the assembly on top of the method and extend the function startup. And then overriding the configuration method, we could add logging, for example, or inject the filters or the services that we want. So this was plain simple. You're going to be sending which are the routes, the type of the function, and that. And we can switch to a Net5 application where we can see simple differences. For example, now we have, as I mentioned, the program where we can configure the worker defaults. In this case, I'm adding a middleware here. And also I'm configuring the services for that, where I'm adding the logging or adding the services scoped. If we want to add a middleware, we need to create a middleware separated that is going to be implementing this interface, the RE functions worker middleware, and you're going to be invoking it. In this case, I'm running a simple authorization that is just checking this string as a part of the header. As you can see, you can now access the entire request and also the response. I found out a way to get the request. There's no built-in way to access it. You have to access it through the code to the context, the binding context and binding data. Then you're going to have the request. I have here just to show a method that gets you the request data. And also we have a way to set the response in case, I don't know, we need to add headers for the response of an HTTP request. There's a way I found in Azure that it's going to be implemented in the future. I assume that it's going to be in the next version of this, but we can check here. If you go to my repository, we're going to have these two different versions of the application to check. It's GitHub / Guillermo Murano / pwv.test app, and well, I can run both to see. I can run this to see what's the difference. So as I mentioned, if you want to run this, we need to go to the folder and run the func host start. And as I want to debug it, I need to declare that it's going to be a debug here. Okay. So as you see, it's restoring the project and adding the dependencies to it. And now we're going to have the application working. And there we have the 4 functions that I built. I have this timer trigger running every 10 seconds. So we are going to see that it's sending messages here. And as I mentioned, if we want to debug it, we need to attach the process to the .NET process. And here we go. So as you see, we have here this message that is just sending the time, and we're going to see this start function, end function. Where am I doing it? If we go to the middleware that I created, you see that I'm accessing here in the pre-execution. I'm showing which function is being executed. And in the post-execution, I'm sending the end message. In case of the HTTP trigger, I can send a postman, for example, to this endpoint. And yes, as you see, I get this response that is a fixed list in the code. And you see here that it says again that the function was executed and that the function ended. Again, this is checking that sort of authorization that is just this key here. If I remove a character here, you're gonna see that I'm handling there that authorization. I can add a breakpoint here to show. There it is. So as you can see, we are accessing the header here. And in that header object, you're going to have the entire headers that we have, and it's going to be checking against the authorization. If if you want to access the full object, again, we can check that this is building the request data based on the values in the properties of the features, checking with this function. You can access it through the features, or even again, as I did it with the binding data. So in this case, we're going to be returning this access unauthorized. And as I'm running this get all, we can see that now it's going to be he's going to do the check against it step by step, and it's going to check if the requests have that item authorization that matches with unauthorized. And from the request, you are going to be creating the response with the status code and the string you're sending. So let's move. And as you see, I'm just sending this 401 message with the message unauthorized in this case. The same way here, you're gonna just be sending without the authorization key, and in the function is going to be checking that. And again, it's going to be creating from the request a response with the HTTP status code with this key. So as you see, I'm just creating the bad request. In this case, you're going to have the full control of what's happening in the application, how the response is being built. You can decide which type of headers and things you need to add. For example, when you need to create a request for success, you need to set the content type that is not included, and the date for it that it's not also included. And in the case of a post, you need also to add as part of the documentation of REST endpoints, you need to add the location. So again, you need to add it by yourself. If we go to the old way of doing it, it's just being handled by the OK object result, where you send just the object you need, and that will do it. As I mentioned before, for the log, you need to send the log here as a part of the application. In this case, I'm handling it on the middleware as a part of the execution context, as you see here. You can also do the same and get it from the function, just writing the same code, accessing through the execution context and getting it from there in order to log messages inside the application. Okay, I think that's pretty much it. What I can show. Let's again. I don't know if there's any question that I can answer.
Hi, Guille. We don't have any questions right now.
Okay, then again, if something comes up in the future, feel free to send me an email, for example, if you want. My email is going to be guillermo.murano@softvision.com. Thank you all. I hope you understand a bit more of what Azure Functions in Net 5 does and how it's being built.